In 2021, a classified contract worth $1.8 billion was quietly signed between SpaceX and the National Reconnaissance Office. No press conference, no congressional hearing. By 2025, that single award had expanded into more than $22 billion in military contracts, spanning spy satellites, classified AI, autonomous drone swarms, and now Tesla vehicles built for the battlefield. One privately controlled ecosystem now sits inside nearly every layer of American defense. They call it the Musk Stack, the private military-industrial complex Eisenhower never imagined. It started in orbit. The official record of the Starshield deal is buried in layers of redacted language and classified procurement codes. In 2021, SpaceX entered into a $1.8 billion contract with the National Reconnaissance Office, one of the largest single-source awards ever extended to a private space company for military use. The contract's existence is confirmed by a handful of investigative reports and procurement notices, but nearly every detail, contract number, technical deliverables, and even performance milestones is blacked out or replaced with the phrase classified NROXKX. On the public-facing government portal, the award value is visible, but the line item is stripped of any identifying information. Only the agency and the dollar amount remain. Within the contract summary, key sections are reduced to a single word: redacted. The technical annex, which would normally outline the satellite bus, sensor payloads, and integration schedule, is replaced with a legal disclaimer referencing national security exemptions. The only unredacted language describes a requirement for proliferated architecture, a term used by the NRO to signal a new generation of satellite constellations designed for resilience and rapid replacement. SpaceX is listed as the prime integrator. The NRO retains ownership of payloads and sensor intellectual property, but the full scope of the technology, infrared sensors, onboard artificial intelligence, mesh networking, is hidden from public view. The first launch under this contract took place on April 22, 2024, with a Falcon 9 carrying an undisclosed number of Starshield satellites into low Earth orbit. The launch manifest, reviewed by Spaceflight Now, refers only to multiple payloads for the NRO reconnaissance constellation. No satellite identifiers, no technical specifications, no public press release. The cadence of these launches and the scale of the award point to a classified system whose coverage is intended to blanket wide areas of the globe, providing persistent surveillance and real-time data feeds to military operators. The structure of the contract and the deliberate opacity of its documentation confirms that the Musk Stack's space layer is now woven directly into the classified fabric of American defense, with oversight limited to a handful of government officials and private executives. The scale of Musk's orbital infrastructure is now measured in thousands, not dozens. According to the Federal Communications Commission's official inventory, as of June 1, 2025, SpaceX controls 7,742 operational Starlink satellites in low Earth orbit. This figure, confirmed by both Federal Communications Commission filings and independent satellite trackers, surpasses the combined total of every other commercial and government constellation on the planet. Each satellite is a node in a global mesh, engineered for constant connectivity, high-throughput data, and rapid reconfiguration. The sheer number allows for near-total coverage of inhabited regions, with overlapping footprints that can reroute bandwidth in seconds. Beyond the commercial fleet, a parallel network is taking shape under classified contracts. By December 2025, SpaceX's own launch manifest documents list 183 reconnaissance satellites delivered for the National Reconnaissance Office, payloads that ride the same Falcon 9 rockets but serve a different master. These reconnaissance units, distributed across multiple orbital planes, form a persistent surveillance layer. They operate alongside the Starlink backbone, but their data streams are encrypted, and their tasking schedules are hidden behind layers of redacted procurement records. The physical dominance of this architecture is not theoretical. With over 7,700 communications satellites and nearly 200 reconnaissance platforms in orbit, the Musk stack has established the largest privately controlled space infrastructure in history. The system's capacity is not just about the number of satellites, but the bandwidth they can deliver, enough to support global AI applications, secure military communications, and real-time sensor fusion across continents. Every new launch expands the footprint, tightening the web of connectivity and surveillance that now underpins both commercial and national security operations. The numbers are staggering, but the implications are even larger. A single corporate network now blankets the planet, setting the technical baseline for what modern warfare and global governance will require. On November 7, 2025, an amateur radio astronomer filed a formal anomaly report with the Federal Communications Commission, FCC. The complaint described a narrow band signal pulsing every 12 seconds at exactly 144 MHz, squarely within the protected 2-meter amateur band. The signal was not a mystery. Its Doppler shift, orbital timing, and intensity matched the path of a classified National Reconnaissance Office satellite, one of the new Starshield units launched earlier that year. The power level, measured at -70 decibels per milliwatt on the ground, was far stronger than any routine Starlink beacon or commercial satellite telemetry. Raw spectrograms posted to a public forum captured the burst, a sharp, repeating emission that cut through the background noise. Within days, the data had spread across online radio communities, drawing in independent analysts and former spectrum regulators. One of them, Dr. L. Ortega, published a technical breakdown speculating that the burst was a diagnostic downlink for on-orbit sensor health checks, possibly relaying encrypted telemetry from the satellite infrared array. But the frequency choice raised alarms. 144 MHz is internationally reserved for non-commercial amateur use. No public license existed for a government payload to transmit there, let alone a classified military satellite. The FCC response was swift but opaque. Its public docket records a letter of inquiry, case reference FCC 2025-144, requesting clarification from the National Reconnaissance Office and SpaceX regarding non-standard emissions from a classified payload. Simultaneously, the International Telecommunication Union logged a complaint entry, ITU 2025-R0012, alleging a violation of Article 5.2-1 on unauthorized transmissions in the amateur band. The NRO issued a brief statement insisting all systems were compliant with United States and international law. No technical explanation followed. For the amateur astronomer and the growing network of civilian analysts, the episode exposed a gap between the official record and observable facts. A private citizen, armed with a software-defined radio and open-source tools, had detected a classified satellite unlicensed transmission before any regulator or oversight body could intervene. The incident left a trail of unanswered questions about the true function of the Starshield payloads, the adequacy of spectrum oversight, and the ability of regulatory agencies to keep pace with a classified, privately operated military network that now spans the globe. The Department of Defense's decision to allow xAI's Grok large language model onto classified networks signaled a new phase in military AI integration. Axios reported that, as of February 2026, Grok is approved for deployment on the Pentagon's GenAI.mil portal, with a contract ceiling reaching $200 million. The agreement authorizes Grok to handle sensitive data and operate in direct proximity to the military's most guarded digital environments. Official briefings confirm the system will be hosted within the classified enclave, with full operational clearance expected by February 2026. This contract is not a one-off experiment. It's the foundation for a new generation of AI-enabled defense infrastructure, where large language models analyze battlefield intelligence, generate operational plans, and interface with secure communications relays. The GenAI.mil framework, established under the same policy that governs the Joint All-Domain Command and Control Initiative, is designed to accelerate the adoption of autonomous systems across every branch of the military. Grok's integration is the first instance of a commercially developed LLM being embedded into the classified core of U.S. defense operations. Defense Secretary Pete Hegseth described the move as a necessary step to maintain technological superiority in a contested world. The contract language, reviewed in DoD procurement records, grants xAI broad latitude for both development and operational support, with the ceiling set at $200 million through 2026. The proximity of Grok to classified data streams, combined with Starshield's orbital bandwidth, creates an integrated feedback loop where AI, satellite communications, and military command functions converge within a single private ecosystem. The boundaries between civilian technology and national security are dissolving, with oversight now a function of contract clauses and executive discretion. A new front in military autonomy opened with the Department of Defense's $1.3 billion contract for autonomous drone swarms. The official request for proposals, issued in March 2025, called for real-time targeting and adaptive collective behavior in unmanned aerial systems, a technical leap that moves beyond remote piloted drones to fully autonomous, AI-driven strike teams. The program office, newly established within the Pentagon's Joint Autonomy Directorate, outlined requirements for swarm coordination at a scale of 1,000 units, with each drone expected to identify, track, and engage targets on the move, without direct human oversight. The contract language, reviewed in redacted procurement documents, specifies delivery of a proliferated, low-latency mesh capable of operating in contested electromagnetic environments. Embedded in the statement of work is a clause for continuous, real-time targeting updates, effective in fiscal year 2025. This provision authorizes autonomous platforms to receive and process live intelligence from satellite and ground sensors, then act on those feeds in seconds. The integration of commercial AI supplied by private vendors directly into the command loop is no longer theoretical. It is a funded mandate. The scale of the award signals a break from legacy defense primes. Instead of a single platform, the Pentagon is buying an ecosystem: AI models, secure communications, robotic airframes, and the chips to power them, all delivered as a package. The program's managers, drawn from both the Air Force Research Laboratory and the Defense Innovation Unit, have described the effort as the kinetic bridge between data and action. In this architecture, the Musk Stack's ability to supply AI, bandwidth, and hardware under one roof is not just an advantage, it is the model. The demand for integrated chips and autonomous robots is no longer a future scenario. It is now a procurement line item, with battlefield consequences that will unfold in the next budget cycle. Terafab stands at the center of this industrial web, a $22.4 billion capital investment disclosed in SEC filings, designed to bring every critical semiconductor process under one corporate roof. Unlike legacy defense contractors who source chips from a patchwork of global suppliers, the Musk Stack now controls wafer fabrication, advanced packaging, and final assembly through a single vertically integrated facility in Texas. Investor Materials described Terafab as capable of producing radiation-hardened processors for satellites, AI accelerators for battlefield computation, and automotive-grade chips for electric vehicles, each batch tailored to the needs of SpaceX, Tesla, and xAI. The facility's leadership, drawn from both semiconductor and aerospace backgrounds, answers directly to a consolidated executive team with oversight of every step, from silicon design to deployment in orbit or on the ground. Optimus extends the ambition beyond silicon. Tesla's Optimus project, outlined in internal presentations and public shareholder meetings, sets a target of 1 million humanoid robots per year, an output that would dwarf the combined industrial robotics production of Japan and Germany. These robots are not theoretical. Production lines formerly dedicated to Model S and Model X vehicles are being retooled for Optimus assembly, with robot planners, software-driven systems that schedule, coordinate, and optimize manufacturing already in operation. The robots themselves are slated to become both factory workers and deployable assets, blurring the line between civilian automation and military logistics. The result is a supply chain that answers only to itself. Every chip, every robot, every AI model is sourced, built, and integrated within a closed loop, immune to outside disruption. The Pentagon's fiscal dependency on this ecosystem is not a distant scenario. It is a budget line, a procurement reality, and a strategic risk. With $22.4 billion sunk into Terafab and a 1 million robot projection on the horizon, the Musk stack completes its circle of self-sufficiency, locking in a model of military-industrial integration unprecedented in modern history. A detailed review of the federal procurement ledger tells its own story. Across 34 separate awards tracked in the USA Spending Database, Musk's corporate network has secured $21.9 billion in U.S. government contracts since 2022. These awards are not scattered side deals. They are concentrated, high-value obligations covering launch services, missile tracking, secure communications, AI development, and integrated hardware for every branch of the military. The contracts include the Space Force's $2.3 billion for National Security Space Launch Phase 2, the Navy's $1.8 billion for Joint Warfighting Software, $3.5 billion from the Air Force for Advanced Missile Tracking, $5.1 billion for the Space Development Agency's Transport Layer, and $4 billion from the Army for the Armored Tesla Initiative. Even xAI appears on the books, with a $199 million DARPA award for AI-enabled intelligence analysis. Each line item is traceable to a formal award notice, complete with contract numbers, award dates, and the full contractual language. The cumulative total, nearly $22 billion, reflects only the publicly disclosed portion. It does not account for classified increments, sole source modifications, or the pipeline of future obligations projected in Pentagon budget documents. The financial scale is not theoretical or speculative. It is a matter of record, visible to any taxpayer willing to parse the federal ledger. This is not just a portfolio. It is structural dependency, with the U.S. defense apparatus now locked into a privately controlled supply chain that spans the entire stack, from launch pad to orbit, from silicon to software. On April 3, 2025, the Department of the Army issued a program objective memorandum requesting $400 million for the procurement of armored-class electric vehicles. The document posted to the Army's acquisition portal lays out a single-source stipulation. Tesla Inc. is named as the exclusive vendor for this new ground mobility initiative. The memo, contract number AR 2025-400, details a phased acquisition plan that bypasses a competitive bidding process, citing Tesla's proprietary battery architecture and integrated sensor suite as essential for forward-deployed operations. Unlike traditional defense contracts that separate platform, powertrain, and software, the Army's approach fuses all three under Tesla's control. The vehicles are specified for use at forward operating bases, with requirements for encrypted communications, modular armor, and autonomous navigation. The justification for sole sourcing references Tesla's ability to deliver both the physical vehicle and the digital backbone, including secure over-the-air updates, battlefield diagnostics, and real-time telemetry through a vertically integrated supply chain. The $400 million request is not an isolated line item. It represents a structural pivot. Land warfare assets, once the domain of legacy defense primes, are now being sourced from a commercial electric vehicle manufacturer whose primary expertise lies outside the traditional military-industrial base. The Army Program Office frames this as a necessary adaptation to emerging threats and supply chain volatility. But the procurement memo also sets up a deeper question. whether the kinetic edge of U.S. ground forces is becoming dependent on a single privately managed ecosystem, with all the vulnerabilities and ethical dilemmas that entails. On February 23, 2026, Senator Elizabeth Warren sent a letter to the Secretary of Defense demanding a full account of the controls on xAI's Grok, now embedded within classified military systems. She cited warnings from the NSA and the General Services Administration, raising the specter of compromised cybersecurity and risks to American personnel. Warren's letter echoed a rising anxiety in Congress about the Pentagon's growing dependence on a single, privately held technology stack, one that extends from launch infrastructure to battlefield artificial intelligence and the chips inside autonomous machines. Months earlier, on November 15, 2024, a DARPA briefing deck circulated among defense officials. The Castelian project, led by former SpaceX Starshield engineers, proposed mass-produced hypersonic interceptors, glide vehicles launched from Army platforms and designed for rapid deployment. The presentation outlined a $2.3 billion development plan and emphasized lessons drawn from SpaceX's assembly lines. Yet, key technical details and contractual links remained redacted, leaving open the question of how much of Castelian's supply chain still depended on Musk's vertically integrated operations. These developments have forced a reckoning in Washington. Congressional oversight, once a reliable brake on defense procurement, now trails the pace and secrecy of private innovation. As ventures like Castelian emerge from the Musk ecosystem, the line between public accountability and private control blurs. The alarm is no longer abstract. It is written into the record, in letters and hearings, with no clear answers about who controls America's most advanced military tools. Today, the Musk stack sits at the heart of U.S. military infrastructure, its satellites, AI, and robotics, now essential for command, control, and combat. As vendor lock-in deepens, the boundary between public oversight and private power blurs. This is not just technological progress. It is a structural shift in who controls warfighting itself. The question is no longer what is possible, but who decides what is permissible.